So this week, I'm going to have you actually analyze some data and develop some graphic images and then interpret them from studies. And so we're going to use this first study here as an example of how you do that. And then you'll have another data set that you'll be analyzing. So this study was looking at the impact of light from computer monitors on melatonin levels in college students. So it is representative of your pool of people right now that you are involved in when you are studying and doing things late at night that might impact your sleep. Right. Oh, okay. Sorry, my thing wasn't moving forward there. So in their study design, they had 21 participants and they were exposed to one of three test conditions. They were exposed to computer monitor only, so the light from the computer screen, a computer monitor viewed through goggles that provided 40 lux of shortwave light or the blue light range. And so the blue light is thought to really activate the wakefulness state, right? And is one of the main responders for lowering melatonin secretion or release. And then the third situation was the computer monitor viewed through orange tinted safety glasses, which is thought to be a better wavelength of light that will not have as strong an inhibition on the melatonin response as the blue light does. So that's their setup. And yeah, so the orange tinted glasses are serving as the dark control condition. A better maybe control would be to have students that weren't looking at the computer monitors right before bed, but that's hard to get students to sign up for that because they need to study and do their work. So that was their control that they used for this study. And then they collected saliva samples from subjects at 11 p.m. before the starting of the computer tasks, again at midnight and at 1 a.m. while performing the computer tasks under all of these different experimental conditions. So this is at a time frame when melatonin levels should be increasing, making you sleepy and wanting to go to bed. All right, and so this is what they found. These are their results. They saw that the blue light suppresses melatonin release and the body's natural rhythm to darkness. So this is their sample with the blue light compared to the monitor alone people and the monitor with the orange tinted glasses that had the most melatonin. Um, so I put in here, would you like to see any other controls? I would like to see what it's like if they weren't using the monitor at all, that they were just a normal sample and not doing anything with the monitor. But they didn't have any of the conditions doing that. So when you're looking at graphic representation of data that's been collected, I think you need to think about a few things that are going on in the study. First, the sample size, and I don't have that on this graph, but the sample size is important because the bigger the sample size, the more statistically relevant your data is going to be. This is a fairly small sample, right? They only had 21 people that were in this study. So having a larger sample size is going to give you more statistical significance. Although they did find statistical significance in this study with two of their conditions, but not the third. So that's kind of what I wanted to point out here is what is a p-value and what do the error bars present in their data collection. So you can see there's error bars included here, and then they've got these p-values that are up here. So the first thing to do is to know that there was a data set that they had to analyze to get this chart, right? So they had 7 people, they had 21 people, right? So 7 were in the monitor only group, 7 were in the blue goggle group, and 7 were in the orange tinted goggles. So their data sets that they were looking at probably looked something like this. So they would have their participants, This is the monitor only group, right? And then they were measuring the melatonin levels at specific time periods. And so this is the 1 a.m. time that they gathered their data. And then for the 7 participants, they would all have a range of melatonin secretion during that time. And then what's shown in the histogram is the average and the standard deviation, right? So if you're looking at the monitor only, the average is up here at about 17.5, so right in between 15 and 20. And the error bar is this range around this region. How much variation did they see in their data, right? And so the average is what's shown, and then the error around that average is called the standard deviation. And so I'll show you how to calculate both of these values here to make a data chart. So in your assignment this week, you're going to be given some data sets that you will need to use to make a graph like this, essentially. But it won't be for monitor use before sleep. So to take an average, you need to take all of these values here and you need to add them together and then divide them by the total number of participants. So that's our N number in this case, and our N number for this is 7. So if we add up all of these values, divide by 7, that is going to give us our average for the sample. That's also called the sample mean. So you'll see both of these in reference to this value here. Adding in the units is also very important. So you want to make sure that you're maintaining the units in your measurements and the significant figures, like how far these data points go out. You don't want to increase your significant figures here. So calculators will just give you a big dump. And so, once you divide by 7, you might have 17.48657, whatever. You want to round up and make sure that you have the same number of significant figures in your data that's collected. So calculating the standard deviation is a little bit more difficult. We tend to use this equation here, and you had a StatQuest tutorial that talks about the standard deviation and using these calculations, right? So the sigma unit is the unit that is the standard deviation, your population standard deviation. N is the size of the population. So in this case, how many people that you measured, and then whether that is the total population or a subset of the population that you're measuring. Typically, when we do experiments, we can't measure everybody in the population to get an exact number and find the exact mean when you get this normalized histogram type of diagram, right? So we typically will underestimate the actual mean when we are collecting a subset of the population. And so that is the X bar here, is the estimated population mean. That is this number here that you've calculated by calculating the mean of your data set. That is X bar. Okay, so you can calculate X bar. The real population mean is the exact population mean is mu. So oftentimes you might see mu up here in this equation as well. If you measure everybody in the population, then this is the true population mean. But usually you can only get an estimate here. The chi values here or x values here, these are for the individual experiments that you've done. So for each measurement that you make for each person that's a participant in this, you'll have an xi value. So for person 1, that's 17.4. For person 2, that's 18.6. Right? So that's what this term here, that's your individual values that you've calculated for each sample in your data set. And then this term here is a summation term. So that means you have to do this function for each value that you've collected from your data set. So we have to do this 7 times for the current data set and subtract off from the mean and then square that value. And then we have to add them all together. So if you're calculating the standard deviation by hand, it would look something like this, right? So the first thing, I need my average, which we calculated first. This is this value here, the x bar or chi bar. And then you're going to need to calculate this unit for each of the measurements that you've made. So that's what's calculated here. So for each one of these measurements, I need to subtract the mean, square the value, and then get that number. So that's what I've got down here. And then I'm going to follow what this tells me to do. This is the summation. So I need to add up all of those values that I just calculated. And then I need to divide that by n minus 1. So my n number is 7, minus the 1 is 6. So that gives me a value of 0.72 in this case. And then you need to take the square root of that value, because that is also in our equation, and that gives me 0.84. So that is the value of my standard deviation for this data set. Okay, so that's how you calculate standard deviation in this area here. And then evaluating your p-values. P-values are used to evaluate the null hypothesis. So you had a StatQuest tutorial that you were supposed to watch on the null hypothesis. But the null hypothesis is essentially the hypothesis in where your expected does not happen, right? So in this case, we would say that none of the monitor conditions make a difference. So we have 2 null hypotheses in this one, right? Well, 3 actually. The monitor alone versus the blue light. The null hypothesis would be that there's no difference in melatonin. You could do the monitor only with the orange light. So you could compare those 2 variables and develop a null hypothesis. And then you could also compare the blue light and the orange light goggles and also have the null hypothesis that there's no difference between them. The alternative hypothesis is that there is a true difference. So when you're looking at your p-values are going to tell you whether you're going to reject or accept the null hypothesis, and this provides you a way of determining the significance. So typically, if you have a threshold of 0.05 for your p-value or lower, this has to be reached to rule out the null hypothesis and then support the alternative hypothesis of interest, which is what you wanted to study in the first place. You want to see if monitor exposure affects melatonin levels, right? So that's how you evaluate your P levels. This is the significance level that you're looking for or lower. So if you're at 0.05, this is essentially 5% of the time you're going to be wrong in your assessment of the situation or less. And that's an acceptable statistical error rate for most studies. So when you're doing hypothesis testing, right, you can have error. And so I just said 5% of the time you're going to make errors based on this probability or p-value. And so either you can have a type 1 error or a type 2 error. So in the type 1 error, you're going to reject the null hypothesis when it's in fact true, right? So if you're thinking about a criminal case, for example, so your null hypothesis is that you have a saint and they're not guilty of the crime, right? So in the null hypothesis situation, if you accept the null hypothesis when it's true, you've got the correct decision. But if you reject the null hypothesis when it's true, then you're going to send an innocent person to jail. That's a type 1 error. So when you reject the null hypothesis when it in fact is true. You have this other situation, right, where you reject the null hypothesis. If you reject the null hypothesis and the alternative hypothesis is true, you've made the correct decision. And in this case, melatonin is going to affect, melatonin levels are going to be affected by monitor use. That would be the correct decision there. Or you can make a type 2 error, and in this case, you're going to accept the null hypothesis when it's not true. And this is going to be a type 2 error. And in the case of a guilty person, the person's guilty, but you've said, oh, no, they're not guilty. And now they're going to be wrongfully acquitted and they're going to get away with the crime. So you can have these two different types of errors that you can make in any kind of study. You'll have a type 1 or a type 2 error. And that depends on whether you inappropriately reject or accept the null hypothesis. So the p-value is how often you're going to make these types of errors. And so we say a 5% error rate. If we're only making that error in 5% of the cases, we're okay with that. That's significant enough. It's better if you've got better error rates, right? So if we take a closer look at the p-values from this study, if we compare the monitor only to the blue light goggles, we can see that they have statistical significance down to 0.005. So this is actually 0.5%. So this is a much higher statistical significance than we would require normally. So this looks like really good data. And then even better if we're comparing the monitor with the blue lights to the monitor with the orange lights. You've got even more statistical significance. It's down to 0.1%. So I'm only going to make a mistake every 1 in 1,000 times or 5 in 1,000 times in between these cases. However, they didn't show you the p-values between these two cases. And that's because these ones are not significantly different from each other. And so they cannot, they would be making mistakes and rejecting the null hypothesis more often if they were comparing the monitor only with the orange tinted goggles. Okay. All right, so that's our statistical overview. In your study this week, let me see if I can find where I have your class open. See if I can bring that over there. All right. So in your assignments for this week, you are doing kind of a similar assessment for your assignment. So you've got two documents that you'll need to download for the assignment. The melatonin data is held in Excel, and then the actual assignment and questions are in the document file. So the document file is the one that you'll need to follow through and answer questions in. So you'll want to open that and follow the instructions that are in there. And I believe I have that open as well. So let's make that go away. So here's the melatonin activity. And whoop, I can shrink this a little bit. And then I've also got the melatonin data file open as well. Let's make that a little bigger. And just let you see it a little bit better. Maybe this guy too. Okay, So I've given you a little bit of background here on the circadian and sleep homeostatic mechanisms regulating quality of wakefulness. We've been talking about that today. And so in this study, they're wondering how daytime caffeine intake will affect melatonin levels, right? So this is similar to what we just saw with the monitor only, the monitor with blue goggles, and the monitor with orange goggles. So in your data set that you've got, this is your example page, right? And then your homework data is on tab 2. So to get to your homework data, you want to click down here on tab 2, and that will bring up your data set that you'll be working with in this study here. So they are looking at their methods. They have 20 male young volunteers that participated in this randomized double-blind study. You can tell that this was study done in Europe. They swap out the S's for Z's and in uh, their English language version of the English language. But they had three study conditions as well. So they had people taking caffeine pills, 150 milligrams, 3 times a day for 10 days. They had people doing a placebo, so a sugar pill, 3 times a day for 10 days. And they also had a withdrawal situation. So they let people take the caffeine 3 times a day for 8 days, and then they switched them to the placebo for 2 days. So the people didn't know which ones they were taking. They were just given their pills. The pills all looked the same. So starting on day 9 of this treatment, that's when they started making their measurements. They were looking at salivary melatonin and cortisol levels. And then they were looking at evening nap sleep, as well as sleepiness and vigilance performance throughout the day. So they had them in the laboratory for the last 43 hours so that they could do light control and posture controlled study protocols. Because as we've seen, light can cause variation in melatonin levels. So they had to control for those elements in the study. So the first thing that you need to do is to develop your null hypothesis and your alternative hypotheses. You've got 3 conditions that you're studying here. So you've got 3 null hypotheses and 3 alternative hypotheses that you can develop for this study. If you want to create a single null hypothesis, that's fine, that there's no effect in any of the variables or situations. But you should develop your 3 alternative hypotheses for the comparison variables, right? So you could compare the placebo with the caffeine. You could compare the placebo with the caffeine withdrawal. And you can also compare the caffeine with the caffeine withdrawal. So you can make all of these different comparisons and make hypotheses for what you think are going to happen. Okay, so that's the first part. And then you will need to calculate the averages and the standard deviations. So for the placebo control, you need to show your work. So you need to hand calculate the averages and hand calculate the standard deviation for the placebo control for this data set. But Excel is, of course, an amazing program, right? And Excel will do this for you, right? So if you haven't used functions in Excel before, I'll just show you how to do that. You can look these up and you can search for these on the internet too if you need to figure out, how do I do an average or a mean? But you start by putting an equal sign in your frame. And for the average, you just type in average. And that is going to give you the formula that you're looking for. And then for the cells that you want to take an average of, you're going to put in a parentheses, and then you're going to grab what you want to add together. So in this case, I've got my, 7 participants, and I'm going to average them together. and then put the end parentheses, and then when I hit enter, it is like magic, right? It does the calculator dump essentially for that value. So I noticed that, my values are only, to the first decimal place. So I need to round this value. You can do that easily in Excel up here as well. You can press on this little arrow and it will pull back and it will do the rounding for you. Magic calculator in Excel. So you need to do this by hand once so that I know you understand how to take an average. But for the other data sets, you can go ahead and do the average using Excel. Same with the standard deviation. There is a formula for standard deviation. There are, in fact, multiple formulas for standard deviation. I am using the stdev.p version. So that's the one that you should use as well for yours. If you used another one that they have in the formula, it's not a train crash, and I won't mark you off for that. But it's the same. So you'd start with equals stdev.p. This is going to give you the same calculation that we're using, or same rounding that we're using in the formula that I gave you that you're going to do by hand. So it should match what you calculate, right, for your standard deviation in the trial. So if I take this set and I grab it all here, and then I'm like, what are the standard deviations between this number? You can see it's giving me 0.8139. I'm going to walk that back again to the first decimal place. Boom, 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 boom. Come back. And then I've got 0.8. So we walked through the standard deviation, how to do that by hand in the lecture today. So you've got that lecture slide that's posted. You can follow that for doing that by hand for the placebo trial on your homework data. So you'll need to do that by hand for this data here, and then you can check your work by using the Excel functions to do the average and the standard deviation in your tables. Okay, so you'll need to do that for your homework, right? And then you'll need to also develop a third table where you list your averages and your standard deviation out. When you list it in this format, so that you've got these columns with your averages and standard deviations, it becomes really easy to make a graph, right? So if I grab these guys, well, oh, no, I only want to grab the first two to make my graph. You can insert where's my graphs? Oh, over here. So here you can have a recommended chart. So I'm going to go in and I'm going to click on that. I want this kind of chart here. So I'm going to click on that. You can see it gives me monitor only, monitor with blue goggles, monitor with orange goggles, and it's titled it for me. So I'm going to grab that, pull that in. You can move these graphs around on the page. So I can move, got to grab the whole thing. I'm just going to move that down so I can show you the one I just made. The one I just made doesn't have the axis label in here. So if I go up here at the top, when I'm selected on chart design up here, I can add chart elements to this. And so in there, I want to add an axis title, and I'm going to add a title to the primary vertical. So I can put that in there, and then you can just click in here. Maybe I can click in there. And then you can put in what you want for the title. So this is melatonin, and it's picograms per milliliter. I can put that in and then leave that there. My x-axis is labeled nicely with what I put in as my conditions. And then the title, I think, is fine. It's showing overall melatonin concentration. And that's that. You can see there's no error bars in here yet. So if I go back into, where'd my chart layout go? Chart design. Here, if I add a chart element, there is a selection to add error bars, right? And so you should be able to add standard deviation. This is not showing up right. But if you hit the more option, so it's asking, go down and select the custom here, right? And when you specify your value, you want to select your standard deviation range right here. Well, and you have to do that for the positive and the negative. I almost missed that, right? So this area, you need to select that as well, right? Because the error is plus or minus above and below the average value, right? So you can be varying around it. And so now I've put in my error bars using my standard deviations that I calculated. You can check your graph to make sure that you got your error bars in there correctly. You can see both of these are at 0.8, so they look the same. That looks good. This one is 1.7 and it's wider, and it looks wider on my graph too. So my error bars are now in there. So that's, if you select on your graph, you get into this chart design area, add chart element, go to the error bars, and standard deviation. You want to get into your more options for adding the standard deviation. Oh, I just messed up my bars again. The go back feature is helpful. Okay, so that is your assignment, is building this graph, copy paste it into your data over here, and then in your homework data at the very bottom, it has p-values for your comparisons, and you just need to evaluate these. Is it significant? Are you going to accept or reject your null hypothesis, and what's your reasoning? All right, do you have questions for me?
So do we turn in the Excel file or just a Word document or both?
Just the Word document. So it will ask you to copy paste things in from the Excel file.
Okay.
Yeah, so you'll end up placing your graph in the Word document to turn it in. So there are, let me see, I think 8 questions. 7 and 8. Yes, there's 8 questions in there. The last question, I pulled another data set or a figure from that same paper, and I asked you to interpret it. So you'll do a little graphic interpretation there. Yep. So only the Word document is due. You can copy paste in from the Excel into the Word document in there and arrange spacing as you need. Other questions? Oh, is there some in the chat? Let me see if I can find the chat. Yes, I am recording this. I will post this up. I know there were a few people that could not be here today as well. I will separate them, I think, if I can figure out how to do that so that you can have that the last part of the recording. I think it will help you the most with the homework. And so I'll try to separate that out. There are also very good tutorials on the null hypothesis, p-values, and standard deviation that are also posted in week 7 from the stat quest. And it's a very good video tutorial on what those things are and how you develop the hypotheses. So go back and watch those too as you're going through this exercise. Yep. And then if you have further problems, shoot me an email. Let me know. I'm happy to work with you and help you out. Any other questions? Thank you for sticking with it today. I was going to spread this out over 2 days this week, but with all the weather being so bad for people and people not having power on Monday, I think having it on one day was a little bit better for us, even though it was a long push today. Yeah. All right. You guys are free to go then.
Thank you.
Yes. Thank you.